Hi everybody, Mrs. Pesic here. We're looking at section 2.4, which is completing the square. Your objectives are to solve quadratic equations by completing the square and to write quadratic equations in vertex form. Your vocabulary for this lesson is completing the square. Many quadratic equations contain expressions that cannot be easily factored. For equations containing these types of expressions, you can use square roots to find your solutions or your roots to the equation. So here's our square root property. To solve a quadratic equation, you can take the square root of both sides of the equation. Be sure to consider both the positive and negative square roots. So for example, if we have x squared equals 15 and we're trying to solve for x, we can take the square root of both sides. When we take the square root of both sides, though, we need to remember to include the plus or minus. And that means the square root of x squared, the square rooting and the squaring are canceling each other out. So we're left with just x equaling positive square root of 15 or negative square root of 15. If x squared equals a, and a is a non-negative real number, then you're going to have two solutions, positive square root of a and negative square root of a. All right? So we read this as plus or minus the square root of a when we see that symbol. All right, so let's take a look at this example. We are solving equations by using square root property. So if we want to solve this equation, the first thing we're going to do is we're going to subtract 11 from both sides. So we get 4x squared equaling 48. Next step would be to take, actually, before we take the square root, we're going to have to divide both sides by 4. So we're going to get x squared equaling 12. At this point, now that we have x squared by itself, we can take the square root of both sides of the equation, but don't forget, we need positive and negative because there's two solutions possible. So we get x equaling plus or minus the square root of 12. Can we simplify square root of 12? Well, yes, because we can rewrite square root of 12 as square root of 4 times the square root of 3. And square root of 4 is just 2, so we get 2 square root of 3. Don't forget that we had plus or minus, though, so our solution should be x equaling plus or minus 2 rad 3. Let's take a look at, oh, and you could check that on your calculator as well. If you type in 2 rad 3 on the left side of this equation, so I'm going to plug in 2 rad 3 right here, and I get 4 times 2 rad 3 squared plus 11, that ends up being 59, which is exactly what we're hoping to see, right, on the right side. And you can do the same thing with negative 2 rad 3 popped in for x. So 4 times negative 2 rad 3, quantity squared plus 11, also equals 59. So you can check your work on your calculator. Let's try this example. We're solving this equation. 3 times the quantity x minus 8 squared equals 15. We're going to try and solve this by taking square roots, but before we take square roots, let's get rid of this 3 out in front. Let's divide both sides of this equation by 3. Those 3's divide out, and we are left with x minus 8, quantity squared, equaling 5. Now that we have just a quantity being squared, we can take the square root of both sides, and when we do that, don't forget you need a plus or minus. The square rooting here and the squaring here are canceling each other out. So we just get x minus 8 equaling plus or minus square root of 5. At this point, we're still trying to solve for x, but we have an x minus 8 right now. So let's add 8 to both sides, and we're going to put that 8 in front of the plus or minus. So our solutions should be 8 plus or minus square root of 5. So really you have two solutions. 8 plus rad 5 is one solution, and 8 minus rad 5 is another solution. If you wanted to check those on your calculator, you could as well. Just pop in 8 plus square root of 5 right here, and 8 minus square root of 5 right there, and you should end up with 15 both times. Just show that it works. Okay, so let's talk about perfect square trinomials. I have some examples of perfect square trinomials here. X squared minus 4x plus 4 is a perfect square trinomial. X squared minus 20x plus 100 is a perfect square trinomial. and x squared plus 18x plus 81 is a perfect square trinomial. What's so special about these perfect square trinomials? Well, each of them can be rewritten as a binomial squared. Each of them can be rewritten as a binomial squared. And the binomial is always going to start with x plus a number or x minus a number. In this case, it's going to be x minus 2 quantity squared. And you could check that. You could multiply x minus 2 times x minus 2 using FOIL. We get x squared minus 2x minus another 2x plus 4. And sure enough, we end up with this exact same perfect square trinomial. This one here, the x squared minus 20x plus 100, could factor into x minus, what do you think it's going to be? It's going to be x minus 10 quantity squared. Again, you could multiply out x minus 10 times x minus 10, and when you do, you're going to end up getting right back to this trinomial here. What about this example? X squared plus 18x plus 81. That's a perfect square trinomial that could be factored into x plus 9 quantity squared. So how would we make our own perfect square trinomial? Let's say we had something that was x squared plus 16x. What would I have to add here so I could make a perfect square trinomial? Well, let's look back and see if we can see a pattern here with these. All right, I'll get rid of that. And get rid of that. Okay, so what I'm hoping you're going to notice here is, for example, in this one, if I took half of negative 20, that'd be negative 20 over 2, that's negative 10, and if I square that, I'll get this. So half of negative 20 is negative 10, and negative 10 squared is positive 100. Does that same thing work on all these? Half of negative 4 is negative 2, and then negative 2 squared is 4. That works. Half of 18 is 9, and then 9 squared gets me to 81. And by the way, notice that this number here is always the number that's going to be filled in. Minus 10, there's my x minus 10. Negative 2, there's my x minus 2. 9, here's my x plus 9. So now that we've looked at that pattern, can we figure out what we should have right here in this blank? Well, let's follow that same pattern. We're going to take half of 16 is 8, and then 8 squared is going to be 64. So 64 was the number that we needed to make a PST, a perfect square trinomial, and then x squared plus 16x plus 64 can be written as a binomial squared. What would that binomial be? Well, remember, here's your clue right here. That's the number that has to go in with the x, so it's going to be x plus 8 quantity squared. All right, so this is how to make perfect square trinomials. So the methods in the previous examples can be used only for expressions that are perfect squares. However, you can use algebra to rewrite any quadratic expression as a perfect square. So if a quadratic expression of the form x squared plus bx cannot model a square, you can add a term to form a perfect square trinomial, and that process is called completing the square, because you're making a perfect square trinomial. All right, so here's our example. To complete the square of x squared plus bx, you're going to take half of b, which is b over 2, and you're going to have to square it. So that's why it's saying add b over 2 quantity squared. So let's take a look at this example here. We've got x squared plus 6x. What would we need to add to make a perfect square trinomial? We'll take half of 6 is 3, that's 6 over 2, and then square that, and that's 9. So that's why we want to add 9. X squared plus 6x plus 9 is one of those PSTs, perfect square trinomial, which can be rewritten as a binomial squared. All right. So let's take a look at this example. Complete the square for the expression. Write the resulting expression as a binomial squared. So x squared minus 14x plus what would make a perfect square trinomial? Take half of the negative 14, that's negative 7, and then square that, and that gives you 49. So this one should be x squared minus 14x plus 49 to make a perfect square trinomial. Then it says write the resulting expression as a binomial squared. So hopefully you are understanding that that's going to be x minus 7 quantity squared. All right, let's take a look at example 2b. Complete the square for the expression. Write the resulting expression as a binomial squared. Here we have to take half of 9, which I'm going to leave that as a fraction, 9 over 2. And I'm going to have to square that. So when I square that, 9 over 2 squared, 9 squared is 81, and 2 squared is 4. So I really have to add 81 over 4. So I should have x squared plus 9x plus 81 over 4. This is my perfect square trinomial. And it can be rewritten as a binomial squared. What would that binomial squared be? Remember, here's your clue as to what goes in with the x. So it should be x plus 9 over 2 quantity squared. Again, you could multiply out x plus 9 over 2 times x plus 9 over 2 using FOIL. And when you do, you would end up getting right back to x. All right, let's take a look at these steps for solving a quadratic equation by completing the square. So first step is to collect variable terms on one side of the equation and constants on the other. As needed, divide both sides by a to make the coefficient of the x squared term equal to 1, because you cannot complete the square unless it's a 1x squared plus something x, right? And then you would add something. But this has got to be a leading coefficient of 1 here. All right, then you're going to complete the square by adding b over 2 quantity squared to both sides of the equation. We talked about that. And then you're going to factor the variable expression as a perfect square. That just means rewrite both sides. Rewrite, well, not both sides, but rewrite as x plus b over 2 quantity squared. Then you're going to take the square root of both sides of the equation and then solve for the values of the variable. So let's take a look at how this works. We've got x squared plus 12x plus 36 equals 28. Now, before we get ahead of ourselves, let's check. Is this already a perfect square trinomial? Is this a perfect square trinomial? Question. Well, let's check it. If I was to take half of 12, that would be 6. And then if I square 6, is that equal to 36? It is. So I don't have to do anything as far as adding b over 2 squared. It's already there. That means this is already a perfect square trinomial in this box. So I can rewrite it as a binomial squared equals 28. So x squared plus 12x plus 36 could be rewritten as x plus 6 quantity squared equaling 28. And then to solve this, I would take the square root of both sides. So let's take the square root of this side of the equation, square root of this side. Don't forget that plus or minus. The square rooting and the squaring cancel each other out. So we get x plus 6 equaling plus or minus square root of 28. And we are going to want to get x by itself. So we're going to subtract 6 from both sides. But let's put that minus 6 in front of the plus or minus. So we're going to have x equals negative 6 plus or minus the square root of 28. Can we simplify square root of 28? I think so. It can be split up into square root of 4 times square root of 7. So that's 2 square root of 7. So we should have x equals negative 6 plus or minus 2 square root of 7. So it means you really have two solutions, negative 6 plus 2 rad 7 and negative 6 minus 2 rad 7. And if you type those numbers in for x here and here, one at a time, then you will see that you do end up getting a true statement because you will get 28. So if we try negative 6 plus 2 rad 7 squared, that's right here, and then we're plugging it in right here. So we gotta have 12 plus negative 6 plus 2 rad 7 plus 36. It ends up being 28, which is what we're trying to get. And it works with the negative 6 minus 2 rad 7 in both of those places as well. So that's a little check you can do on your calculator. All right, let's try this example. Solve the equation by completing the square. X squared equals 12x minus 20. Remember, your first step is to get all of the terms with x's on the same side. So I get x squared minus 12x. And even if I added 20 to both sides, let's just try that for right now. If I add 20 to both sides, is this a perfect square trinomial? Well, is half of negative 12, that's negative 6, is negative 6 squared equal to 20? No, so that's no good. This is not a perfect square trinomial, so that means we really don't want this 20 here. It's messing things up. So let's bring it back over to the other side by subtracting 20 from both sides. So we really have this, and notice I'm leaving some room here to complete the square. The leading coefficient is a 1 on the x squared, so that makes it okay to try and complete the square. We're going to take half of negative 12 is negative 6, and we're going to square that, and that gives us 36. So this is a perfect square trinomial now, but I just added 36 to the left side of the equation. So now my equation is not in balance. So to balance it off, I have to add 36 to the other side of the equation. All right, and then I have x squared minus 12x plus 36. Now this is a perfect square trinomial, so I can rewrite it as a binomial squared, and it's going to have to be x minus 6 quantity squared. Remember, here's your clue as to what goes in with the x. And then equals negative 20 plus 36 is 16. And so now we're going to have to solve this equation. So we already have a binomial squared, and we like that, so we're going to take the square root of both sides. Don't forget the plus or minus. The square rooting and the squaring cancel each other out, so we get x minus 6 equaling plus or minus, and the square root of 16 is 4. So it means we really have two equations, x minus 6 equals 4, or x minus 6 equals negative 4. So to solve this, we're just going to add 6 to both sides, and we get x equals 10. Or if we add 6 to both sides here, we get x equals 2. So these should be our two solutions, 2 and 10, for this equation. Let's just try one of those. If I plug in 2, I get 2 squared. Is that equal to 12 times 2 minus 20? That's 4 equals 24 minus 20. Sure, 4 equals 4. So that works, and it should work if I plug in 10 also. 10 squared equals 12 times 10 minus 20. That's 100. Is that equal to 120 minus 20? Sure is. Again, 100 equals 100, and it works. All right, so we like those solutions, x equals 10 and x equals 2. Let's try and look at this example. Solve the equation by completing the square. So first let's put the 3x squared term first. I get 3x squared plus 18x equals 45. All right, at this point we want to solve by completing the square, but remember we cannot solve by completing the square unless this leading coefficient right here is a 1. Since that's not a 1, we have a little problem, and so we want to actually divide everything. We want to divide everything by 3 so that we get a 1x squared plus 6x equals 15 in this case. Notice I left some room to complete the square. So what do I want to add? I want to take half of 6, which is 3, and then square the 3 to get 9. So I'm adding 9. Why am I adding 9? So that I can create a perfect square trinomial, which can be rewritten as a binomial squared. But if I add 9 to the left side of the equation, I'm going to have to add 9 to the right side of the equation also to keep the equation in balance. So now that I have this perfect square trinomial, I can rewrite it as a binomial squared, and it's going to be equal to, looks like 24 on the right when I add 15 and the 9. So x squared plus 6x plus 9 could be rewritten as x plus 3 quantity squared equals 24. And now I'm ready to take the square root of both sides. taking the square root of both sides. Don't forget you need that plus or minus. The square rooting and the squaring are canceling each other out. So we get x plus 3 equal plus or minus the square root of 24. All right, and you could simplify that square root of 24, because square root of 24 could be split up into square root of 4 times square root of 6. So that would be 2 times the square root of 6. Don't forget, that's plus or minus. And it was x plus 3 equals plus or minus 2 and 6. So our last step would be to get x by itself. We're going to need to subtract 3 from both sides. But let's put that negative 3 in front of the plus or minus. So we're going to have negative 3 plus or minus 2 square root of 6. So really, two solutions, negative 3 plus 2 rad 6 and negative 3 minus 2 rad 6. You could plug those into your calculator to check them to make sure that they work in the original equation. All right, let's take a look at this. Remember that the vertex form of a quadratic function looks like this. F of x equaling a times x minus h quantity squared plus k. To rewrite a function from standard form into this vertex form, you can first find the vertex. So what do we mean by standard form? Well, standard form of a quadratic function is f of x equaling ax squared plus bx plus c. And we've studied quadratic functions in this form, and you know that you can find the vertex by finding the x-coordinate first using this little formula, x equals negative b over 2a. All right, so let's take a look at an example where we're going to put something from this standard form into vertex form. So let's take a look at this example. Here's our standard form right here, and we want to put that into vertex form. Remember, vertex form is a times x minus h quantity squared plus k. So let's first start by identifying the vertex. This is in standard form currently. So the x-coordinate is going to be negative b over 2a. My a is 3, my b is negative 18, and my c is 7. So I want opposite of negative 18 over 2 times 3. So that's going to be positive 18 over 6, which is 3. So our vertex is going to be 3 comma something. So let's plug this 3 in for x here and here to see what we get. So we really want to find out what is g of 3. So it's going to be 3 times 3 squared minus 18 times 3 plus 7. And so when we do that, we get, let's see, 3 times 9, got to do the squaring first, that's 27, minus 18 times 3, so that is 54, I think. You can check me on the calculator, but I think we get 27 minus 54 plus 7, and so that's going to be a negative 27 plus 7. I think that's going to be a negative 20. So I think our vertex is 3 comma negative 20. So if we know that, we can fill in the vertex. Remember, the vertex is your hk. So 3 is our h, and negative 20 is our k. So we want f of x equal a times x minus 3 quantity squared plus negative 20. Or I could just write minus 20. But we can't leave this a here. What's the a going to be? Well, the a in standard form, let me go back to this page for a minute. The a in standard form is exactly equal to the a in vertex form. They're equal to each other. So back in our example, our a was 3, so I can just fill in 3 right here. So our final answer for vertex form should be 3 times x minus 3 squared minus 20. So that's how you rewrite a function from standard form into vertex form. All right, that's it for these notes. Thanks for watching. Have a great day.